Okay, so the next topic we're going to go into is, again, staying on this theme of alkenes reacting with other stuff. So here's a very similar alkene to what we've seen in the past. So we've got our double bond and 1, 2, 3 carbons on this molecule. So nothing too terribly crazy about this, but what we're doing is, up to this point, the only thing we've really reacted alkenes with have been, we've had HBr, we've had, acid catalyzed water addition, so H plus cat, and then also the last thing we did is a very similar thing with it, which is just the methanol with H plus cat. So up to this point, we've done 3 different types of additions on alkanes or alkenes. So HBr, H2O, and some kind of alcohol. So water and alcohol, both of those had to be acid catalyzed. We're going to add a 4th type of addition to an alkene reaction, and what we're doing is we're still adding halogens like we did with our original example, which was HBr, but now we're adding 2 halogens that are now bonded together. So this is the difference between HBr and Br2. So we've got 2 halogens instead of 1. So this is our dihalide, so Br2, and so what's going to happen is I'm just going to give you the overall reaction scheme. We'll talk about the mechanism in the next video, but for now all I'm going to give you is the A plus B equals C kind of reaction. So I'll go ahead and letter or number these carbons 1, 2, and 3. And so if I draw my reaction arrow, what you'll see is that actually when you contrast to the water and the alcohol additions, we're not actually going to need catalysts. So the Br2 addition is actually very similar to the HBr addition in that we don't need any kind of catalyst for this to work. So then the final product for this kind of reaction is going to be we're converting our alkene to an alkane. And what we're going to have on the alkane is 2 new substituents. So this is carbon 1, carbon 2, and carbon 3. And so now originally carbon 2 had 1 hydrogen coming off of it, and carbon 1 had 2 hydrogens coming off of it. And those 3 hydrogens are still going to be present. So 1 off of 2, and then 2 off of 1. But now we've added 2 new atoms to the molecule. So we're adding bromine here and a bromine here. So overall, we've added 2 bromines to the alkene, and we've converted the alkene to an alkane. So this is going to be called, this molecule has a very specific name, and it's called a dihalide. And the subcategory is called vicinal. So this is a vicinal dihalide. And what the vicinal is telling you is, the vicinal term is giving you information about the relationship of bromine right here to this bromine right here. And what the vicinal is saying is that the bromine 1, or bromine A, I guess, let's call this A and this is B. Bromine A is 2 carbons away from bromine B. So these 2 bromines would no longer be referred to as a vicinal dihalide because the 2 bromines are bonded to the same exact carbon. They no longer have 2 carbons separating them from each other. So that vicinal is very specific in terms of the spacing of where the bromines go. So with the HBr addition, we said that the alkene acted as a base. It didn't act basically, like very simply, it acted as a base in an acid-base reaction. But now what we're going to find out in the next kind of video where we talk about the mechanism is that we can no longer refer to this alkene double bond or the electrons within this blue bond right here. We'll no longer be able to refer to those guys as a base. They're going to actually turn into what's called a nucleophile, or we've introduced this term before, but they're no longer going to act basically, they're going to act nucleophilically. Okay, so we'll talk about that in the next video.